For the fifth experiment entitled Half-Life, this experiment aims to help students develop an understanding of half-life and radioactive decay. The materials that are used in this experiment are a shoebox and lid, 200 pennies, and a graph paper. In this experiment, the group members decided to place all 200 pennies in a single shoebox and cover it with its lid. We then shook the shoebox and opened it in order to determine which pennies were represented as heads or tails. After the group has completed distinguishing both the heads or tails, we were left with this data. As shown in the data, the group began by shaking the shoebox containing 200 pennies, and after the first shake we removed 100 pennies, leaving an equal number behind. With each subsequent shake, the number of removed pennies steadily decreased. 50 on the second shake, 28 on the third, 13 on the fourth, 5 on the fifth, and finally no pennies were removed on the sixth shake. Although 4 remained, the pattern continued with 2 pennies removed on the 7th shake, no removals on the 8th and 9th shakes, and 1 removal on the 10th shake, leaving just 1 penny. The 11th shake resulted in no removals, and on the 12th and final shake, the last remaining penny was removed. This sequence of shakes and removals demonstrated the concept of halving the initial quantity with each successive round, imitating the decay process. Now for the guide questions. For the first question, what is the meaning of the graph you obtained? To this question, the group answered that the graph illustrates the gradual decrease in the number of pennies represented through a decay curve. Following each shake, the remaining number of pennies experiences a consistent reduction, roughly equal to a 50% decrease. This means that with each successive shake, more or less than half of the initial number of pennies is removed, contributing to the overall diminishing trend observed in the graph. For the second question, approximately what percent of the remaining pennies were removed on each shake? Why? The group responded with approximately half of the pennies are eliminated in each shaking round due to the fact that every individual penny carries a 50% probability of landing with its head facing upward, since one penny can only have 2 outcomes. This means that with each shake, an even chance exists for each penny to be positioned heads up or tails up. Consequently, this balanced probability leads to the removal of approximately 50% of the pennies during each shaking action, resulting in the gradual reduction observed. For the third question, each shake represents a half-life for the pennies. What is meant by a half-life? To this, the group answered, a half-life signifies the duration required for the quantity of a substance to decrease to precisely half of its initial amount, or from any given level to a point exactly halfway between the level and its original value. In essence, it's a fundamental concept in the decay process, demonstrating the point at which something attains half of its original quantity or achieves a 50% reduction relative to its initial state. In respect to the graph, each shake indicates that the quantity of the peonies is reduced in about half. This concept is widely used in various fields, including physics, chemistry, and biology, to understand the decay or transformation of substances over time. So now moving on to the conclusion. In conclusion, the graph illustrates a decay curve that shows how many pennies are lost over time, with each shake resulting in about 50% reduction in the number of pennies left, because with each penny has a 50% probability of landing heads up. Roughly half of the pennies are taken out with each shaking, leading to the constant decline. This process represents a half-life, which signifies the time it takes for a substance to decrease to half of its initial quantity or reach a point halfway between its initial and final values. This concept is essential to understanding decay processes in various scientific fields. For the reflection, through this experiment we were able to understand the concept of half-life as a rate of decline. This concept is a great help, especially with radioactive materials which are harmful to humans. Through half-life, we are able to determine whether a material continues to be dangerous or active, which indicates if the material has broken down.